Good morning, everyone. Let's try that again. Good morning, everyone. Perfect.
Hi everyone, I'm Donovan Brown, Principal DevOps Manager here at Microsoft, and today I have my guest is Munil. Munil, introduce yourself to everyone.
Hi everybody, my name is Munil Shah. I'm a Director of Engineering in the Visual Studio Team Services team.
Perfect, and I'm really excited to have you here because I do a lot of our transformation talk, where we tell about how we here at Microsoft and the Visual Studio Team Services team are migrating ourselves to this new DevOps mindset. And I've had a lot of higher level conversations, but when I kept wanting to dig deeper, they said you were the guy who could actually explain to me how we could actually start to do this. Now, I tell the story about how we do a ring deployment, where we deploy to different rings. And from what I understand, those rings are made up of scale units. So before we get too technical, can you please define for me what a scale unit is and what a ring is and how those apply to our deployment?
Yeah. So a scale unit at a most fundamental level is just a unit of scale, because we have hundreds of thousands of accounts on our service. A scale unit is a multi-tenancy collection of accounts in a particular data center.
Okay.
And a scale unit has let's say a few 100,000 accounts, and then once we achieve that scale, we stamp out another scale unit. And so in each, so that's how we get presence across the globe, and we have scale units that are spread out across the globe. There are some in US, some in Europe, some in Asia, and we place the scale unit close to where the customers are, so they get great performance. But it also allows us to get this horizontal scale on the product.
Got it. So a scale unit sounds like we build or we reserve resources in Azure, because Visual Studio Team Services runs in Azure. And based on the VMs we're using, I believe we're not using PaaS, we're not using IaaS, we're using cloud services.
We use PaaS. We have ATs and we have JAs.
Okay.
And each scale unit will have a minimum of three AATs and 2 JAs.
Okay.
But some of our scale units are pretty big, and they can have multiple 10, 15 ATs and multiple JAs. And that just depends on the size of the
so what are they? You're using some acronyms there. So explain the acronyms for us that don't know what the acronyms are.
ATs are application tiers,
right,
and JAs are the job schedulers.
Exactly. So there's also a database behind all this stuff too.
And
so
we use SQL Azure for database.
So does each scale unit have their own database that matches it, right? So I'm going to have all
each scale unit has databases for the customers.
Okay.
So if you have in a given scale unit, if you have let's say 100,000 customers, then they're packed inside a set of SQL Azure databases.
Great. So I have a SQL Azure database that supports my jobs, that and also supports my application tiers. And my application tiers are running in cloud services.
Right.
Right. So, and that defines a scale unit.
Yes.
And they usually have the capacity of 100,000?
Yeah, I mean, it varies. So in some cases, we have a scale unit dedicated to a particular region. So let's say we have a scale unit for Brazil.
Okay.
So it, depending on this number of accounts we have available in Brazil, that scale unit will have that many accounts. In some a region like US, where we have lots and lots of accounts, we have scale units in West region, we have scale units in East region. Just for performance sake, we have scale units in multiple data centers and regions.
And as we get more customers and we start to tax a particular scale unit, we would stamp out another scale unit and start putting new customers there. Right. So that's a scale unit. It is the resources that we have in Azure that host a collection of customers on Visual Studio Team Services.
Right.
And I would assume that we deploy to those scale units, not all at once, but through a mechanism.
We follow what we call safe deployment practices.
Okay.
And it's just a way of controlling risk in a live site environment, because any change that we deploy to live site has the potential to cause some disruption. Of course, we would like all changes to flow smoothly, but we are deploying changes all the time, sometimes multiple changes per week. And so we want to do it in a very safe manner. And one of the ways we do it is this practice called safe deployment practice. And what it is that we look at our entire environment of, let's say, a couple dozen scale units, and we group them into rings. And these rings are, think of them as progressively, the rings get progressively bigger. So we start with what we call ring 0. Ring 0 is where our scale unit 0 is, and scale unit 0 is our own team. So the Visual Studio Team Services running in the cloud on the same VHTS service is housed in scale unit 0, and that's part of our ring 0. So we deployed to a scale unit 0 or ring 0 first, and our team get to experience the new change first, and if there is a problem, we would notice, we are the first ones to notice.
Absolutely.
Once that looks good, and we live the new change on a sort of major deployment, we live it there for a day, and a day or two, and we observe it, and then we go to ring 1. Ring 1 typically is a small scale unit, so it's, again, the change is not exposed to a very large set of customers. So we'll pick a small scale unit, let's say Brazil, and we deploy it there, and we observe how that change is doing. We have lots and lots of telemetry that we collect on the product. So we get a lot of insights just by looking at and monitoring the telemetry, but we can also keep an eye on sort of any feedback we may be getting from customers. Once we feel good enough with that ring, then we go to a next ring, this ring 2, where ring 2 is one of our larger scale units. It happens to be one in US. So now we have gone from our own scale unit, ring 0, to a small scale unit in ring 1 to a large scale unit in ring 2.
Okay.
And once we feel good about that, then we are now starting to roll the change out to a multiple scale units at the same time. So now ring 3 and ring 4 have multiple scale units.
Gotcha.
And so that is how a change will progress through our lifesite environment. So it could take a change, if it's a small change like a hotfix, it could go through this rings fairly quickly, within few hours. But if it's our major sprint deployment, a change can take more than a week to go through our entire environment.
Interesting.
So that's why when we come out and say, this sprint release, we have these features, not all features are available to the customers at the same time, because those changes are getting rolled out in a progressive manner.
All right, great. So you said a couple of things there that were quite interesting. First is ring 0 maps to a single scale unit.
Correct.
Ring 2 maps to a single scale unit.
Ring 1 maps to a single scale unit.
Yeah,
ring
0,
2,
1, and 2.
Correct.
But beyond that, there's multiple scale units in each ring.
Correct.
How do you decide how many scale units are in each ring?
I think we are very thoughtful about these first 3 rings. The philosophy is the first scale unit being our canary scale unit, that is our own scale unit. Then we wanted the next scale unit to contain next ring to contain just one scale unit that's small enough, so that we can, again, outside of our own team environment, because remember, our team MSN is a special case, so we want to see how the change deploys to a real customer scale unit. So that's how we picked a small scale unit in ring 1. Ring 2 is now we build up enough confidence to take risk into a bigger scale unit. So that's how we deploy to scale unit 1. At this point, we have built enough confidence that we feel like this change can go out much faster. So that's why we start to group more scale units in the next set of rings. Ring 3 is where we have some of our big accounts, internal big accounts in Microsoft, because VSTS is heavily used inside Microsoft. So we have like our Azure team and the DevDiv team, and number of big teams in that scale unit 3, as well as some of the external scale units. And ring 4 is pretty much all of the above.
So we're 4 units now? Is that how many 4 rings? Is that how many rings we have today?
4 rings, yeah.
We have 4 rings today that encompass all of the scale units. So by the time that feature gets to ring 4, it is now in the hands of everyone.
Correct.
All right. Now you mentioned that could take as long as a week to happen, because it bakes for 24 hours in each ring.
Yes.
So we'll deploy it into ring 0. All the Visual Studio Team Services team will get it. It will sit there for 24 hours while we do our daily work inside of it.
Yeah.
And should something bad happen, then we would be the only ones affected.
Correct.
And then you would be able to then send out a hot fix for that, and then we would just start it over again, right? That deployment would go out and sit for 24 hours.
Right.
And then if it worked, then we'd send it to Brazil.
Yeah.
So where are we? Do we do any performance testing before we start deploying it, or do we get our performance metrics as it starts to progress through the rings?
It's a little bit of both. So
Okay.
what we do is, for specific feature where we have very specific performance goals. So let's take GBFS as an example, where GBFS, when we roll, had very specific performance goals in mind.
Okay.
So we did quite a bit of internal performance testing to see where we are with related to those goals, and So that happens before the change is pushed out to production.
So do we have scale units in, first of all, GFS is the Git file system, for those who don't know. We're really bad at acronyms here, so I just want to make sure. So the Git file system was designed so that we could have not binary file, but just large numbers of files for Office and for Windows and things like that, right? So great. So the whole point of that file system was to be fast, because if you use normal Git on Windows, it was unusably slow. So when you wanted to do performance testing of that feature before it started to roll out, do we have scale units that are just for performance testing?
Yeah, that's a good point. So we have this thing called Go Big environment, and Go Big environment is a production-like environment, but it's an internal environment with synthetic accounts and large number of accounts. So we can, and in fact we do, every new sprint deployment goes through a Go Big environment where we run a set of performance tests, and we collect a lot of metrics, and we observe metrics along with sort of just the event log and various telemetry that we've collected to see if there are any performance as well as any functionality issues resulting from just running service at high scale. But philosophically, what we have observed is that over time, we are starting to rely more and more on what we learn from the production telemetry, because there is nothing like production. We can build a very production-like internal environment, but there is no way we can simulate the load that we see in real environment. And this is where the safe deployment practices come into play, because again, because as the change is rolling out through different sized scale units, we are able to collect telemetry in real time and and able to kind of synthesize how the performance of the service is doing and take actions based on that. What we have is for entire product, we have instrumented performance metrics. So for each scenarios, let's say open a work item or create a pull request, we have what we call CI events or customer intelligence event that collects a performance metric from the web browser perspective, and we can observe how that scenario is performing in production, and we measure that against the SLAs that we have created for each scenario. So we define 50th percentile SLA, 80th percentile SLA that each scenario needs to complete within 3 seconds, things like that. And through the performance telemetry that we are collecting from production and observing how it does compared to the SLA, we are able to measure how the service is doing performance-wise in real production.
Great. So I've spoken to Aaron several times on a concept that we use called feature flags.
Yes.
Now we just talked about safe deployment. We now understand what a scale unit is, and we understand that we deploy code through rings. But once the code gets to ring 4, does that mean all the features are lit up?
Not necessarily.
Okay.
Many of the features do get lit up that way, but there are some features where we have concern about whether we have got the right user experience or not, and we want to collect a lot more feedback from customer. So there is a completely independent practice from safe deployment practice called, we call it early adopter program or stage model. Essentially, it's a way to manage exposure control of the feature of a new feature. So if you're, let's say, introducing a brand new pull request experience, and we believe we've got it right, but we want to collect feedback before we actually blast it to all the customers. So while the change is completely deployed, it could be that the feature is completely turned off at that point. And then we progressively turn the feature on using this technique called feature flag. So that feature is coded in a way that can only light up if a particular flag is turned on for a specific account. So what we will do is we will turn that feature flag on for, again, our SU0 account, which is our own team account first, and I'll let our team use that experience first. And this one, we can stay in that feature flag on mode for multiple days. It doesn't have to be just the 24 hours. As long as we, we are getting feedback and we feel like, I think we have achieved sort of optimal experience, then we can turn it on for the next stage. And in the next stage, we typically have some of our closest customers, if you will, or more, what I would call them, some of our most forgiving customers who are like our MVPs or
our friendlies.
Friendlies, and they get to experience that new feature or new experience and give us feedback. Once we feel comfortable with that, then we turn on the feature for optionally for what we call stage 2. I'm sorry about that. I should have turned that off.
No problem.
So in stage 2, we will typically have a set of customers who have been anxiously waiting for a new feature that they have previously asked. And so we know that if we turn on this new feature for these customers, they'll be eager to try it and give us feedback. So that will be our stage 2. And once we feel comfortable with that stage, that's when we turn it on for all customers, which is in stage 3.
Okay.
So this is just a way of rolling out a new feature, collecting feedback, iterating on the feedback, and making the feature better.
Gotcha.
Sometimes we do a third level of exposure control. I know this terminology gets really confusing, but it's all about managing risk and iterating on a feature based on feedback. So occasionally what we would do is we will have the feature turned on, meaning deployed to all scale units and all accounts, but there is a notion of a preview flag. If you go to our Visual Studio settings, you can personally you can go and opt in and opt out of a feature.
Correct.
So that's just another way of so if there is when we use this technique is where there is a fairly not disruptive but fairly new experience that we are introducing, then we would put that feature behind a preview flag. So while it's completely deployed and available to all accounts, it's not on by default.
Correct.
Where you have to go into the your profile setting and manually turn it on. And by manually turning it on, you are opting to use that feature in this new way and give us feedback. And then once we feel like everybody's satisfied with that new feature and it's kind of working well, then we make that when we switch the default and make that on by default.
So is that like 2 different feature flags then? There's a flag that says make sure that it's been deployed in if they wanted to see it, they could see it. That's one flag. And then there's another flag saying, I actually want to see it. So is that implemented as 2 flags in our code as well?
It's the preview flag, the preview notion is not done through a feature flag.
Okay.
That's just a completely different mechanism.
Okay.
But the feature flag is so think about it this way. Feature flag is a on-off switch that we control for customers, and the preview is an on-off switch that customer controls for themselves. Or an individual user can control it for themselves.
But if I turn that feature flag off, the one that we control, then that preview would disappear altogether. Got it. So I also noticed that the telemetry that you get when you use preview is if I previewed it and I turn it off, right? That's information that I wouldn't get if it was just a feature flag without preview, because you're forced to use it because we've turned it on for your particular stage. And even if you hated it, you're just going to have to grin and bear it. And I've noticed that when we realize that people turn on a feature and then turn it back off, that's valuable information. They
that's super valuable.
Like it.
In fact, what we do is that we use that to guide a decision whether that feature is ready for on by default. Because I'm trying to remember which feature. I think it was the new build UI. When we rolled out, we would then go back and frequently check how many people opted in and then how many people opted out. Because an opt-out is a decision that customer made, and that is telling us something about it. That maybe perhaps they didn't quite like that experience a whole lot. So I think that's a very important data point to collect.
All right. So we know we have 4 rings. It sounds like we have 3 stages.
We have, let's see, stage 0, 1, 2, and 3, right? Because 2 is optional. So actually 4 stages.
4 stages starting from 0, right? And we also have a ring 0.
Technically, there is
5 rings then.
There is 5 rings. Technically, there is a ring 4A also, but it's an internal ring dedicated to our Windows customers, our Windows division, because it's so large and it is running on this special database that is not SQL Azure because it's so big.
Gotcha.
And so we deploy to that scale unit the last.
So why is it 4A and not 5?
Because that's a good question. I think it just so happens that we deploy to both ring 4 and ring 4A at the same time. So there is no delay. Unlike if it was ring 5, then there would be a delay from ring 4 to ring 5. These are 2 rings that we deploy at the same time, ring 4 and ring 4A.
Gotcha.
But they happen to have a 2.
Great. So 4A has a single scale unit in it?
Yeah.
Yeah, but 4 has multiple scale units.
Lots of
it makes it a little bit different too.
Yeah,
okay, interesting. So maybe it's the timing that chose that particular one. Now, something else that you said that was interesting, and we kind of hit on it again, was how fast stuff gets deployed. If you're doing a normal 3-week sprint deployment, it sits in things for 24 hours before it moves on. But a hot fix, you said, doesn't do that.
Yeah.
Right. So are those 2 separate pipelines? How does the change know if it should go fast or if it should go slow? And what does going fast look like? What does that mean? Is there no testing? How does it how do we decide that?
No, that's a great question. So anything that we put out in production goes through fairly rigorous testing. So one of the things that we have done over the last couple of years is that we have completely transformed our test infrastructure.
Okay.
And we took the tests that we had that were developed over many decades or over a decade for our on-prem product, where we had the luxury of testing for days, if you will, or for hours. In this new world where we are deploying, at a pretty fast cadence, we had to retool our testing. So in the last 2 years, we've gone through this exercise of converting all the old tests and rebuilding them in this new framework, L0, L1, L2, and L0, L1s are, think of them as unit tests. So what we've done is shifted away from this big monolithic end-to-end test that used to take a really long time, and they were they were not as reliable because they'll be flaky, there'll be errors, and we moved them to a lot more of these unit tests that run really fast, they are very reliable, and we run close to 50,000 unit tests just in our CI process. So by the time a fix comes out of a change comes out of the build process, it's already gone through pretty significant amount of testing. So even within hotfix deployment, we are able to, we may not run all our tests, but we are able to run pretty good number of our tests. And even a hotfix goes through a fairly rigorous CI test cycle.
So it goes through pull requests and things like that?
Yeah.
Because I know our pull request runs over 41,000 unit tests just in a PR.
Exactly,
right.
yeah. And then after PR, we do we produce the build, official build, and then we run another battery of tests, and and that covers a fairly nice area of the product.
You said you've been porting some of the unit tests to a new architecture of unit tests. Did it also require you to change the architecture of the application to be able to be more thoroughly and safely tested with unit tests versus integration tests? Because it sounded like what you were doing before, these end-to-end tests, that's integration testing. And it becomes flaky because there's so many external dependencies all in different stages that when I recorded my test, I had one assumption, that assumption is no longer true, so the test may pass or fail at no fault of the code. So you said we wanted to shift away from that to more unit testing, but not all code that was written a decade ago is really ready to be unit tested. So did you have to change the application as well?
We did have to change the core framework that test framework that we had used in the past to support this new L0, L1
but did you also have to change the actual application being tested is what I was wondering.
Not a whole lot.
Okay. Great.
I mean, we do have some what we call our on-prem tests that are still written in the old framework, and that we've not managed to convert. But by and large, most of our tests have been converted.
Got it. So a hotfix, is that a separate? Because we dog food here. So release management is used to deploy VSTS, right? Yeah. And I always joke.
So we have a template for deploying a dog food, and we have a template for deploying our main sprintly deployment. And so you ask the question, how many hours does it take to get an hotfix out? And hotfix, goes through this 4 rings, fairly rapid sessions. So if it gets deployed to S0, within the next hour gets deployed to ring 1, then ring 2, ring 3, and ring 4. So I think within 5 to 6 hours, a hotfix can get deployed all the way out.
And the time in between each ring, is that controlled by a human or is that automated?
No, it's part of the release management template that we have. So it's not. We can always override that, but by default it follows a particular sequence.
Right. So what I'm asking is that is there a human being that gets sent a notification to approve after 24 hours, or does it automatically after 24 hours go into the next ring?
It automatically goes up.
Got it. So then my question, and again one more time, if we have a path that says every 24 hours go to the next ring, do we have a separate path that says every hour go to the next ring, which is for hotfixes? Is that how we do that?
Yes.
All right, so there's 2 different release pipelines. Got it. One for hotfixes. And the only difference between those is the amount of delay between one ring deployment to the other ring deployment. Okay, great. So we've talked about scale units, safe deployment, rings, and stages, which is amazing. So when we're moving through those rings, though, there's several different types of changes that are being deployed. There's database changes, there's binary changes. which order do we deploy when there is let's assume we have a change that's going to change our binaries and the schema of our database. Which one gets deployed first, the schema or the binaries?
We deploy the binaries first, and that binary change has to work with both the old schema and the new schema. So what we call, that's an ATDT compat mode, and what we do is when we deploy to our first scale unit 0, we deploy just the binaries, and then we wait for 24 hours. So that allows us to make sure that the new binaries are working well with the old schema, and so it's designed to work with that ATDT compat mode.
So what's that acronym?
Oh yeah, sorry, application tier and the data tier. So
okay.
We want to make sure that the binaries and the schemas, they work together.
Perfect.
In a backward compatible manner.
Okay.
And then we deploy the database change. Once we've made the database change, we cannot roll back. And before that, if there is an issue with the binary, we have the ability to roll back. But
gotcha.
once we have deployed the databases, we don't roll back.
Got it. So we deploy out the app tier, and we let it sit to make sure that we don't have any assumptions over the shape of the data, that it understands the old schema and it still functions as it should against the old schema. And then we use it to make sure. And if it doesn't perform correctly, then we can just basically put the old binaries back, no harm, no foul.
Correct.
We'll go make a change, produce new binaries,
Correct.
and try it again.
Right.
And then we're like, okay, great, the new binaries are out there. Now, interesting thing is that those new binaries clearly have new functionality, new features in them, but none of those features light up because they're still running against the schema that doesn't support that particular
Correct.
feature. And then once we're safe with that, we then deploy a new database. Now, the system offline,
No.
right? Deployed while it's running. So once the new database is deployed, that's when we know, okay, there's no going back. We're past the event horizon. But do the new features just start lighting up because the new database is out there, or are they still behind the flags that we have to turn on?
So if a feature is behind the flag, then obviously it doesn't light
Sure.
up. But otherwise, it will light up. Not all features are behind feature flags. We choose which features we want to hide behind feature flags. Again,
Okay.
it has to do with how we feel about the feature, the risk, and how much feedback we want to collect from the customers. If there are, let's say, I'm making a performance improvement of a particular feature, there is no reason to put that feature behind a feature flag, because who's not going to like a performance improvement? So
Gotcha.
Those type of features, they just get rolled down.
Right. Okay,
But
got
if
it.
you're making a UI change, like I said, if you're introducing a new pull request, then you want to hide it behind a feature flag and then progressively disclose it, because you want to collect feedback, tweak it a little bit, and once you are fully satisfied, that's when you want to make it available to our customers.
All right, good. Because I remember, because Aaron has told me like all new features go behind feature flags, but a performance improvement isn't a new feature, really, right? So what I think is the safer say is all new features are behind feature flags, but all code changes are not behind a feature flag.
Absolutely.
All right, great. Yeah, I think that. Yeah, okay, great. So that now we're consistent again. So how are we managing the database schema changes though, right? There's partners of ours like Redgate who have tools for that. We have SSDT internally that would work against SQL Azure. We have code first migrations. So so my question is, we have a schema change. How in the world are we running?
We have our own servicing stack. It's a proprietary servicing engine that we wrote, and we wrote this when we were doing the on-prem TFS. And that's what we use today.
Continue to use, but we now use it in an automated fashion as part of our pipeline. That will go out and make the database change. So we're doing the binaries first. So what happens when we have not only a schema change, but the shape of the data has to be changed? So we've added a new column that is now maybe the aggregate of two other columns we want to delete. How do we allow the data, because we're talking enormous volumes of data. This isn't something that happens instantly. These are transformations of data that could take hours or days.
Correct.
How do we deal with that type of change? Does the servicing model deal with all that for us as well?
Servicing model will deal with that. Typically, it does by service host at a time. So think of it like it makes the schema change per account, and sometimes these changes can last a couple of hours.
Okay.
And when we have a big schema change like that, again we use that go big environment to make sure that we can estimate how long it's going to take in the production, because we don't want a servicing change to be blind to how long it's going to take in production, because sometimes a servicing change, if it's not done right, can take more than a day or two.
Sure.
And obviously we have optimized our servicing engine tremendously over the time to be able to do this kind of schema changes very efficiently. I think there have been only a couple of occasions that I can recall where we had to take an actual maintenance window to do a schema change, because it was fairly significant schema change. But that was probably a couple of years ago, the last time we did it. And again, that was for only a few minutes that we had to take a maintenance window. But otherwise, we are able to do most of our schema updates just online and within few hours after each deployment.
Interesting. And I also noticed that when we describe the way that we do the databases and the binaries, the order is very interesting, because you say we lay down the binaries first, we make sure the binaries work against both current and future, and then we deploy the database and then we're done. You could also go the other way, right? You could literally do your database changes first, not the binaries, and then make sure that your future version of your binaries, right? Because you're doing a database.
If you deploy binaries first, then remember your old binaries have to work with the new schema, and sometimes you made schema changes in a way that the old binaries cannot understand. So that's why to kind of keep our world more sane, this is the order we have.
Right, because if you do the database, if you do it the other way and you do your database first, then your database schema has to support your current code and your future code.
Right.
And it sounds like you've just said it's easier for us to change our binaries code faster than it is for us to go change stored procedures or tables. Because when you do the database first,
in fact, imagine a world where, and in fact, we are going to go to that place where we may make binary changes a lot more frequently. In fact, almost every single day. But the schema changes we may do only on a sprint boundary. So that's another reason why we operate this way, and where many features don't require schema changes.
For sure.
Schema changes are not that common.
Sure.
So that's why we want to be able to operate in a world where you can update binaries very, very frequently and roll out new features. But schema changes is more of a kind of a roll forward point where you cannot go back from.
Right, and it also allows you to make more drastic changes to your schema in one step. Because if you deploy your database first and it has to support the old one and the new one, and you want to drop a column, you can't drop that column just in case you roll your binaries back. That column still better be there. And then you have to then, if you want to delete a column, it takes 2 deployments to do that. Because not until time plus 2 could you roll back and still not need that column. So I understand now why you've chosen it. You can do either way. It just depends on which one is easier for you to actually be able to change. So the only other thing that I was thinking about is not only do we do the database, but you also do things like the versions of APIs and things like that. Those have to be deployed out into the environment as well. How do we deal with some of the APIs and multiple versions of APIs and from what I understand, if I'm writing an API that relies on the next version of you, I can still be deployed sooner than you. Is that true? What I'm saying is that here I have an API version 1.0, and I want to deploy version 2.0 that also relies on your version 2.0. But you're still at version 1.0. I can still be deployed with all my 2.0 functionality, and everything is still going to work. And then once you become 2.0, then I just magically start using that 2.0. It's almost like the same architecture I'm assuming you're using for the database, right?
You're talking about service-to-service calls?
Yes.
Yeah. So there we use the API versioning to negotiate which API you're using when you're talking to the other service. And because you cannot assume that all services are deployed at the same time. So as we are adding more features, some of the new features that we are adding them through microservices. So they are not just part of the main TFS service. And these services can get deployed in different order. They're not all deployed at the same time. So if you're doing a service-to-service call and you're expecting a specific API version on the other end, you do need to negotiate that.
Right. So our code is basically saying, I would like you to be at version 3. You're not. Okay. Then I'm going to downgrade gracefully to version 2. You're there. I'm going to keep using that. And then on the next session, then they can go back and say, hey, are you at 3 yet? And then start to use that information. All right. Great. So this is like, it's fascinating. Some of the stuff that we do. I don't think people understand just how complicated a deployment like this actually is, to as many scale units and to as many rings that we're actually maintaining. So I really appreciate you taking the time and shedding the light on that.
Of course, yeah. Thanks for the opportunity. Sorry if I threw in a lot of different acronyms. They become part of our
vernacular. Exactly,
so
exactly. But I think I double-clicked on most of those. If someone watching the show, we said an acronym we didn't explain, just leave us a comment. We'll definitely go back in and explain that. But again, when you're talking about a large-scale live site application like ours, it's really important to know how do we deal with the deployments on a system that can never go down. And I remember Brian Harry shared that with me. He's like, never, ever, ever can we take this system down. We have to deploy it while it's live.
One of the interesting thing is that the safe deployment practice that I talked about, these rings, is actually a practice that's used across all of the Azure services inside our cloud and enterprise division. So the nice thing is that all our major Azure services are following very similar practices, and so you get some sort of a consistency. For example, our scale unit 0, where our own instances, all services have scale unit 0, and they're all housed in the same data center. So again, what it does is that if there is a let's say new version of compute being rolled out, and us going through the same safe deployment practice as compute, we're able to take advantage of the changes that are happening in a particular manner in the compute, and not cause sort of this mishmash of how the changes get rolled out to customers.
Awesome.
Yeah.
I'm probably going to have you back because we've gone a long time and I'm sure people are going to be taxed, but I'd love to talk to you about live site incidences.
Oh yeah, absolutely.
And how we deal with that, how we identify when is even happening, how do we identify who has to get paged and get on the bridge. So we're going to go ahead and pause now. We're going to be done with this video, but in the future we're going to have Munil back and blow your mind on that. Thank you so much for watching, everyone.
All right, thank you.
It was awesome.
Yeah, all right,
thank you so much.
Yeah, of course.